Yeah, we know you guys. You have lots of stuff to do, so yeah, we're just fine with it. So we don't have stuff to do.
Okay, cool. So I have the homework open and also the group quiz open.
Okay, perfect. So we can get started. Do you want me to start, Andrew, with the answers?
Yeah.
Okay, so part 2 for the design the study. What is the research question? We came up with the mean age at death differs from any of the 3 categories of the novelists, poets, and nonfiction writers. And
Okay,
then,
that's about what I got to.
okay, perfect. And then it says state the null and alternative. It says for the null, all the means are equal, and for the alternative, one or more of the means differ from the others.
Cool, that's what I got to. For 2, collect the data, describe the data collection procedures. I got, we do not know exactly how the data was collected, but we do know that they looked at the ages at death for female writers in North America.
Perfect.
And then did you do the paragraph, the short paragraph summary? 3A. Did you happen to do
Oh,
that?
3A, yeah. So in the short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. So I said that students should have, oh wait, wrong part. So I made a box. Do you want me to read off the numbers?
Yeah, that'll work.
Okay, so for N, the first one, I got 67, second one, 32, 324, and then the total of all of those for N was 123. And then for the mean, I got 71.45 for the first one, 63.19 for the second one, 76.88 for the third one, and then calculating that mean, like the mean of those 3, I got 70.36.
Okay.
And then standard deviation, 13.052, 17.297, 14.097, and then I got for the total 15.104.
Okay, perfect. Did you get an email from our instructor today or yesterday?
Yeah, was it the one about using SPSS?
Yeah. I was just wondering because we've been using Excel and we've enjoyed, it's worked for us. We like it, but I don't know if we have to use it or if he just wants us to use it.
I think he just wants us to use it.
Yeah,
because I've been using Excel too, and I don't know how to use SPSS.
Yeah, and my computer doesn't even pull it up, so.
Yeah, neither does mine. Even in the beginning of the semester, I remember we were all trying to pull it up and it wouldn't connect.
Right.
My wife's will pull it up, but it's kind of hard because hers is the only one that does the video chat too. Mine won't do the video chat, so it kind of bogs down our computer if we're trying to put everything onto it. But
yeah.
So, oh well, I guess we'll just keep using Excel.
Yeah.
Okay. For 4A, it says what type of hypothesis test is appropriate. We said the ANOVA test of several means.
Okay, that's what I got.
Perfect. And then, are the requirements met for this test? Explain. And then, so since they're normally distributed for each group, the first 2 groups of the sample size were greater than 30. So then we saw the normality, that they were normal. And then for the third group, we had to make a QQ plot to test it, the normality.
Right.
And once we did that, the groups equaled 17,297. What was it, point? 17.297, and it's not double the 13.052. So then we could assume that the variances were equal.
Okay, that's what I got too. For D, for the test statistic, I got 6.563. And then for degrees of freedom, for E, I got 120, a whole number.
Okay.
Perfect.
And then the p-value, 0.002 is less than the level of significance, the alpha level.
Right.
And then because of that, we reject the null.
Okay. And then I said that we do have sufficient evidence to say that one of the mean ages of death of the riders is different from the rest, so that means we reject the null.
Perfect. And then action further study. It says, with further study, we find that the poets die earlier than the novelists and non-fictional writers. What significance could you conclude from this? I don't know. As we talked about it, I don't know. It just says that there is a difference. I don't really know, like, specifically why, but there is a difference in the age of the different writers that die.
Yeah.
So.
Yeah, that's what I put too.
Okay. Perfect. So we will go now and start the group meeting. Hold up. Are you ready?
Okay.
Okay. Are you ready?
Yes.
Perfect. Andrew, do you want to read 3?
Yes, and in an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different from the others. Is it one mean or is it 2 means?
Yeah, I think it's at least one or more, so that would be true.
Okay. It's not going up.
No. Keeps popping around everywhere. Okay, so number 4.
Okay. What requirements need to be checked when performing an ANOVA hypothesis test? Let's see. Sample means, let's see. So
Well,
it has to be
variance of the group are equal, so it's C. I think
Wait.
it'd be B and C.
Wait, yeah, I think it would be B and C because it has to be normally distributed, but
As
the
well.
variances are also equal.
Yeah.
Oh, let's see here.
Wait, is it variances are equal? I think it says that, right?
Hold on. I want to go back to number 2.
Back to
Number 3, he's looking at his notes. What does it say?
So to state the null and alternative hypothesis, so the alternative hypothesis, all the means are equal. What is that for the answer?
So, like in the homework for part 1, that's also the answer to question 1 when it's asking what are the null and alternative hypotheses. And the book said, and the answer key said, that the alternative would be one or more means differs from the others, so alternative rejects the null.
Okay.
Okay.
Yeah, it would be true. Okay, and then do you see the requirements? I think it says it's A, B, and C for that. But while he's looking up that one, we can go to number 5. It says to check if each group is normally distributed, do the following when we construct a QQ plot.
Yes. That's what I would say. Because that's also what we had to do in 4C to make a QQ plot.
Okay, yes.
And then 6, we assume the variance in each group is the same if the following happens. If the sample variance for each group is smaller than the sample mean, the largest sample standard deviation is less than 2 times the smallest sample standard deviation. The largest sample mean is less than 2 times the smallest sample mean, or each group has the same sample size.
Isn't it the largest sample size? The largest sample standard deviation is less than 2 times the smallest? Because it
The
says.
largest standard deviation is no more than 2 times the smallest standard deviation.
Yeah.
Is that for variance?
We assume the variance in each group is the same as the following. Yeah, the variance.
Read that out loud.
So if the populations have the same variance, check. So we want to check if the large standard deviation is no more than 2 times the smallest standard deviation.
Okay.
So what does that be?
Yeah.
Yeah. B.
Yeah.
Largest sample standard deviation is less than.
Yeah.
Okay.
Okay, and Nova, I'm going to read that one. 7.
No. Okay. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 2, 3, 2, 3, 2, 3. How many pairs are there when there are 4 samples?
So it's a 2-sample test.
There's 4 pairs. There's 4 samples.
Even samples. There are 3 samples. If there are 3 samples,
There are 3 pairs. Yeah, if there are 3 samples, there are 3 pairs. For example.
So then
when there's 4 samples.
there's 4 pairs when there's 4 samples. Right?
Trick question. That's what I think.
So in the answer, are we just putting 4, or do we have to put 4 pairs?
It won't let you type anything other than 4.
Okay, cool. Number 8, the soccer shoes data has 6 groups, A, B, C, D, E, socks. These data can be found in the wiki. Load all 6 samples into the quantitative inference procedures spreadsheet or perform an ANOVA test in SPSS. Okay, so we have to open up the soccer shoes thing from the book.
Okay. Mommy, what do you...
So you leave today for Washington?
Yes.
Are you flying?
Yeah. Well, I'm taking the Salt Lake Express to the airport, and my flight's really confusing because it goes from Salt Lake City to Phoenix, Arizona, and then to Seattle.
So did you get a pretty cheap flight then?
Yeah.
That works. I think usually sometimes when you do it the cheaper, you do a couple more places.
Yeah.
You go from place to place, and it's more expensive. Just go direct.
Yeah, it's the first time I've had to do that. Usually I get the cheapest one and it goes straight through. So
Okay. So are you taking the Salt Lake Express to Salt Lake?
yeah.
Salt Lake.
Dumb question.
Yeah.
It's okay though.
Well, and I didn't ask that question.
So what time do you get in then?
Into Seattle,
Yeah.
like 1 a.m.
Oh my goodness.
Yeah, and I'm taking the Salt Lake Express from Rexburg at 11 a.m.
Oh my
Oh,
goodness,
man.
a long day of travel.
Yeah, but I'm gonna be in Phoenix for like 3 hours because I have a 3-hour delay.
Okay.
Yeah, that's a 13-hour travel for you.
Yeah, but I have a friend that lives there, so that's good.
Okay. So did you get that pulled up?
I'm getting it right now. My internet keeps disconnecting, so I have to keep reconnecting it.
We will. Okay. What does it want? So it doesn't want the socks. It just wants.
So I have that soccer shoes thing pulled up.
Okay.
So then
We would just copy the numbers over, right?
that's what I would think, but are we using a 2-sample t-test?
You're gonna use the. Oh dang it! You're gonna use the Nova.
Nova. Oh, ANOVA. There we go. Okay. So then each variable is A, B, C, D, E socks.
Yes, that's what I'm thinking.
Okay. Okay. P.
And you're going to, is it Olympia?
Yes.
All right.
Yeah, I'm excited.
Yeah, have you been home for a while?
Last time I was home was for Christmas break. So,
That'll be fun.
yeah, that's a long time for me. I've gone home every Christmas break and spring break since I started school, and then usually 1 week during the 7-week break.
Oh, okay.
But this year for spring break, I went to Las Vegas. So,
Oh, that's fun.
yeah.
Do you think we need to put the socks too?
Yeah, that was one of them. Okay.
Make sure you have the correct amount of 20s.
Yep.
And
So N would be 20, right?
yeah,
Yes.
for all of them.
Cool.
This is, yeah, observe that the p-value is 0.0.
Yep.
And then remove the stocks data, it says. Okay, so remove that data.
So it doesn't want you to put the socks in. You put the socks in to make sure that you get the correct p-value, which we did, and then it says remove the socks.
Data.
Oh, wait. Oh. So remove the socks and then find the new p-value.
Yes.
Okay. Okay. So then for the new p-value, I got 0.309.
0.309.
Yep.
Okay.
The 3 decimal places. Okay.
That would be false. It does not go.
The p-value always goes up when only one group is removed compared to the p-value when the 6 samples are included.
That's false. It went down.
Well, yeah, that one did, but what do you do for the other ones? Do you keep...
No, it says always. So, false.
False.
Remove this one. Then it should go down again. Or just keep undoing then. Keep undoing.
Okay.
That went down it. Again.
So that would be
Do it
false.
again.
You're gonna make me all my hard work. Go down again. We're not. Oh, but it's because I have those there.
So, false.
Yeah. That would be false.
What is the highest p-value you see when removing only one group? Not me.
What is the highest p-value you see when removing only one group? So, it would be...
So we have to just keep removing groups?
Yeah, but it would be this
read the
one.
next. You will need to compute and move up for each possible.
What is the highest p-value you see when removing only one group? You will need to compute an ANOVA for each possible option round to 3 decimal places.
So I think we just have to remove...
Well, wouldn't it be this one?
Yeah.
Is the highest. Or redo your socks. Put your socks back on there. Overlay. Did you already close that sheet?
No. No.
Okay, because then... What's the question? What is the highest value you see when removing only one group? So you want to remove this one, find out what it is, right? Remove that one, find out what it is.
Oh.
Just
That's
like you did
annoying.
here. Now, this one, what it is.
I don't know how to remove it.
Actually, I don't, no, wait, that's not going to be, because it says you need to compute a number for each possible. Yeah, hold on. So there's something that'll do it for us, so maybe, I don't know.
Yeah, I don't know how to do it other than manually.
Let's see, and the thing says before doing ANOVA. Requirement check for ANOVA procedures.
Yeah, we did that.
But then it doesn't show how to do an ANOVA test. Maybe I shut it off before then. But
Okay.
well, this is, it's gonna be that stuff, isn't it?
Well, we know what.
Whoa, what are you doing?
Okay, so that's what it is with that one. Mm-hmm. With that one. Minus, right?
So far. 2.448. Right?
So when we removed the column for variable 3, we've got the highest p-value.
Yeah, same here. Because everyone has, all the other ones had like 0.0 something.
Yeah.
And then did you guys get 0.448 for that one?
Yeah. So let's go with that one.
Okay. And then 12, when all 6 samples are used, what is the maximum standard deviation?
You don't know.
That would be variable 4, right? So 7.291.
Can you just move? You could remove it here and not instead of there.
I don't know. We're looking for the smallest standard.
Largest standard deviation.
For number 11?
Wait. Oh, I put the numbers. I put number 10 and number 11.
Okay. So let's. No, you're good. I'm like, wait. This was different.
Yeah, okay. So number 11, that would be variable 3, right? 5.216.
Yep.
Oh, I can't do it.
Well. Your computer froze. Okay.
Did it let you type in 5.216?
Yeah, mine does.
Okay, hold on. Andrew's computer froze. Just one minute.
Oh, that's okay. That happens to mine all the time.
Okay, so for the smallest one we had 5.216, and then for the largest you were right on variable 4, which is 7.291.
5.216.
Yeah. And then
7.5.
7.291.
Okay.
Right.
Go back up to
I don't have any of
the
those.
highest p value. Okay.
Okay, so the test for equal variance is satisfied for these data.
So the largest sample standard deviation needs to be less than 2 times the smallest.
And it is, right? Because it would be.
Well, it's point.
Yes.
Yeah.
Because the smallest is, yeah, so true.
Okay, so it says construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plot.
Yeah,
And that's using quantitative descriptive statistics, right? That Excel one?
Yeah.
Okay. QQ plots. wait, so, if it's normal based, then it's not supposed, the dots aren't supposed to be spread out, right?
Right.
So when I put in the information for A, all the dots are spread out.
Oh, really?
Yeah.
Okay, let me try it. Sorry, I was just getting it pulled up. It was taking a while, but I finally got it. So let me copy and paste. How do I see? Oh, there it is. Oh, yeah. Yeah, they are all spread out.
All over the place.
So I would say that's false then.
Right. Yeah, and even when I put in B, they're totally different, and they're still spread out.
Well, all of them.
It says that they all have to be.
Instruct you for each of the samples are approximately normal based. Not each. That's not normal at all. Okay. So we at okay, so then it says, do you want to read that one, Andrew?
The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic?
Where's your notes on?
I think it's the right.
Wait. Would it be to the left because the p-value is always less than the F statistic?
Wasn't it in the first slide that it always says? The p-value for this right till. It says it's always right till. But I don't know if that means it's to the right.
So right here,
Well, if it's right-tailed.
p-value is to the right of F equals 4.5.
Okay. So I think it's to the right.
No. Yeah. Okay.
Right? Yeah.
Yeah.
Because it says right here, F equals 4, which is your test.
Yeah.
And p-value is always to the right.
But is that just because the p-value is less than? What is our p-value less than?
Yeah, the p-value is less than the F statistic.
Okay, so then it is to the right.
Okay.
But then, yeah, so it says.
So I don't have it. Just a minute. Did you have any other questions?
I need one. I'll do it. Sorry. Yeah, I don't have any more questions.
Okay. Sounds good. And then let us know when you want to meet on Thursday.
Okay, I think, wait, you guys live in Washington, right?
Yeah.
Okay, so then our time will be the same since I'll be in Washington.
Okay.
So let's do 8 or 9. I'm gonna be at my aunt's house, so sometimes they go to bed pretty early. So let's just say 9 o'clock.
Okay, perfect. And if it changes, let us know.
Okay, so then it will just be 9 o'clock in Washington time.
Okay, perfect. Sounds good.
Okay, cool. Thank you.
You're welcome. We'll see you.
Okay, cool. Bye.
Bye.
Bye.